Hey everyone, welcome to The Explainer. Today we're diving into the absolute ultimate guide for creating highly controlled, stunningly cinematic AI masterpieces, all right from your local computer. We are officially moving way past just typing simple text prompts and hoping for the best. Instead, we're stepping right into the director's chair by integrating the ComfyUI environment directly with the LTX director workflow. It's going to be incredible. Now, you might be wondering, can you actually direct a high-end sci-fi film on a standard local PC? I mean, it really wasn't that long ago that creating consistent, high-fidelity AI generation required massive server farms, or literally a Hollywood-sized budget. But today, the answer is a resounding yes. The barrier between your imagination and a finished cinematic scene has practically vanished. And as you'll see, it's all thanks to this brilliant combination of global reference technology and precise timeline controls. To really anchor all these technical concepts we're about to learn, we're going to use a very specific, highly emotional 8-shot sci-fi script as our test case today. It's a short story we're calling Mia and the Last Natural Rose. Basically, our protagonist, Mia, lives in this dark, cold, metallic cyberpunk world, and suddenly she discovers the very last real flower on Earth. We need the AI to perfectly render that stark visual contrast, her synthetic, gritty environment versus the delicate, organic red petals of the rose. She touches it, smells its sweet fragrance, sheds a single tear, and then, in this dramatic slow motion, the petals scatter in the cybernetic wind. We are going to build this exact sequence, step by step.
Okay, let's map out our journey. Here's the agenda for today. 1. The AI video revolution. 2. The camera lab interface. 3. Step-by-step prompt integration. 4. Inside the ComfyUI backend. 5. Advanced control. And finally, 6. Low VRAM optimization. Let's get to it.
Starting off with Section 1, the blueprint, the camera lab interface.
So setting up your vision is logically split into 3 super distinct areas. Think of the top section as your casting director and global rules engine. This is where you secure your absolute base parameters. Then, moving down, the middle section is basically your storyboard timeline. This is where you map out your shot-by-shot text prompts and animation strength, effectively writing out your entire shot list. And finally, the bottom section is your screening room, where you actually review the final output. It's a brilliant way to keep your entire workflow incredibly organized before we even have to touch a single node in the backend.
Moving right along to Section 2, setting the stage, global reference and prompts.
Look, when you're telling a story like Mia and the Last Rose, consistency is absolutely everything. We need Mia to look exactly the same in every single shot. We pull this off by uploading a global reference image of our actress right into that top section we just talked about. But, a face isn't enough on its own. We need a fully consistent world. So we use AGL's prompt relay to anchor the entire sequence with a custom global prompt. By locking in specific text instructions for things like a high-end, post-apocalyptic cyberpunk environment, moody neon lighting, and an anamorphic lens right at the global level, we guarantee that overarching cinematic theme never drops or changes across all 8 of our distinct shots.
All right, Section 3, storyboarding, the 4-panel Stroll Method.
Now, shifting our focus to the timeline, we get to act as our own storyboard artist using Tudau's incredibly clever 4-panel Stroll Method. Instead of uploading 8 totally separate images, we just upload a 2x2 grid, and the system is actually smart enough to split this apart for us. Check out how specific this timeline gets. You literally bulk paste these exact prompts right into it. Notice the seconds at the start of each line: 2 seconds for the close-up, 3 seconds for her reaching out, 4 seconds for that big slow-motion finale. You are perfectly pacing Mia's emotional interaction with the rose. And what's absolutely crucial here is that LTX Director takes these exact timestamps and instantly translates them into precise frame counts in the back end. It perfectly bridges the gap between your written script and the ComfyUI rendering nodes.
Which brings us to Section 4, the engine room, inside the ComfyUI backend logic.
Let's actually map out the exact step-by-step integration happening within ComfyUI using the What Dreams Cost custom node pack. It's essentially a 3-step data flow. Step 1. You wire up your multi-image loader to receive that 4-panel storyboard. The loader automatically handles splitting and resizing the panels into a proper sequence. Step 2. You pipe that image data directly into the LTX Director node. This is the central hub of the whole operation. It takes those exact frame counts we generated and perfectly links your text prompts to the corresponding image sequence. And then, Step 3, you route the LTX Director's output right into the case sampler, which is paired with a tiny VAE. That combo decodes all this insanely complex latent data into actual rendered video frames at lightning speed.
Okay, on to Section 5,
Advanced control, beating technical headaches. Integrating LTX Director within ComfyUI obviously gives us immense power, but it also solves one of the single most frustrating problems creators face when trying to direct AI. The industry term for this nightmare is prompt bleeding. Basically, this is when text instructions and visual data from one frame incorrectly stretch, merge, and just totally contaminate the following frames. Think back to our script. We have a shot of the rose, followed by a cut to Mia's hand touching it. In standard AI generation, the engine gets confused and might start prematurely blending Mia's hand into the rose petals. It creates this chaotic, messy, morphing soup instead of a clean, professional cinematic cut.
And this is exactly where the LTX Director node truly shines, because it natively integrates Kajaya's prompt relay. Look at the difference here. Notice the clean temporal isolation? Instead of messy bleeding between scenes, the prompt relay isolates the influence of each individual text prompt strictly to its scheduled time on the timeline. So when Mia touches the rose, the AI strictly obeys the cut. The prompt for her hand doesn't bleed backward into the prompt for the solitary rose. It gives us a perfectly clean, sharp transition.
There's also another major technical breakthrough in this workflow when it comes to keeping our characters consistent. See, the base LTX Director node was originally built strictly for shot-level timelines. It literally didn't know how to hold a global reference, like Mia's face, across all those different sudden temporal cuts. To fix this, the developers created an API layer bypass. By using some incredibly clever background Python scripting, the system dynamically injects your global reference properties directly into the runtime frame sequences. This means your overarching character data completely bypasses the shot-level limitations. It forces Mia's face perfectly into every single frame, no matter what the shot-level timeline is doing.
All right, Section 6. This is my favorite part, the great equalizer, low VRAM optimization.
Now you might be sitting there thinking this level of back-end logic requires a massive, hugely expensive server to run. Not anymore. This workflow is the ultimate great equalizer because it allows a standard 8GB or 12GB graphics card to run all of this locally. To pull this off, the source material gives us a step-by-step process with 3 specific hardware fixes. First, you've got to ditch the heavy standard models and use a GGUF model loader. This lets you run 4-bit or 8-bit quantized models, which drastically shrinks your memory footprint. Second, double-check that your clip loader type is set to LTX. This is a massive one. It alters how the text encoder parses data so it stops eating up all your available memory. And finally, swap out standard decoding for the tiny VAE. That simple swap massively minimizes VRAM consumption during the final rendering phase.
Let's wrap things up with Section 7, troubleshooting the set. Okay, we are almost ready to call action on our local machines. But real quick, let's look at a problem solution cheat sheet for a couple of common on-set emergencies you might run into with local ComfyUI environments. If you load up your graph and suddenly see red, missing nodes everywhere, don't panic. It's usually just because the standard update channels are lagging behind. The easy fix is to switch your ComfyUI manager over to the nightly version to instantly grab those latest LTX updates. Now, what if you paste in your storyboard timings, but the timeline widgets are just completely broken or unresponsive? That's definitely a dependency mismatch. The fix there is to force an update on both your ComfyUI LTX video and KJ nodes packages to their absolute latest versions. Just keep those dependencies fresh, and your whole node integration will run smooth as silk.
Well, we've covered a lot of ground today. We journeyed from mapping out a simple 4-panel storyboard, down into the nitty-gritty of API injections and exact ComfyUI node integrations, and all the way through crucial low VRAM optimizations. The barrier between your imagination and real cinematic output has officially vanished. You have the tools, you have the exact step-by-step workflow, and most importantly, you have the control. So I'll leave you with this. What story will you choose to tell now that you hold the director's chair? Thanks so much for joining me on this explainer, and happy directing.